Uh, this breaks out your tasks between the three different areas, between engineering slash programming, computer guy, to math, statistics, your scientist thought process, and then your business side, your domain knowledge. And what I said here is, as far as what all data scientists do, the ones that say all. The ones that say few, only a few data scientists do, and they're probably more along the machine learning engineers. The one here, I got the 3 asterisks by. We will do some of that in here. We will develop a couple of algorithms, especially the neural network, from scratch. That and probably the linear regression, just so you can see where this stuff comes from. I'm not asking you to memorize it, but just so you can see it and program it. So data cleansing. Okay, all of this is about neural networks learning data, learning a pattern, and you feed it data from your system, from your problem that you're trying to answer. You feed it the data. You format it in such a way that the neural network can learn it. That's one of the most important parts of being a data scientist. Unfortunately, I should say, that's busy work. Perhaps it's a lot of SQL, Python. If you're not an SQL person, R. That's one of the biggest things with R. But that's a big part of the computing part of this. That's traditional. That's pulling the data out of your system. Okay, and there's estimates of this being up to 80% of what you do. So if you have a team, this is where you'd want to get somebody who's more in the computing and have them do that part of it. So model algorithm programming, creating the libraries, that's for a few people, like the machine learning experts. Increasing the processing speed, making things run faster. That's another engineering task. That's huge these days. That's what has made data science be where it is. Otherwise, it'd be back where I was in the 90s, not able to do very much, because it would just take too long to train your neural network, train your algorithm, train your model. So, but there's a few people out there that are doing this, and these are our leaders. They're the ones making it possible. They're the ones that are, just blowing us all away with their mentality levels. They're our gods. So that's amazing stuff. Okay, pipeline development. This we will do a lot of. Very exciting. This is where a data scientist lives, is starting with the data, ending with the problem being solved, being to a point where you have results that you can show and explain to the business, to the person that gave you the problem, to your executives. So there's a lot in between. A lot of this other stuff, the data exploration, feature engineering, the rest of these things, and the mathematics, statistics is in that, and the data cleansing. All those are steps in your pipeline development, but that's code. So that's why it's under engineering. You just have to be able to piece together code, to do that. It's not necessarily complicated code. It's more of like your scripting, I would say. So, okay, the mathematics, scientific part, statistical part of this. When you have your data, you need to be able to put it in a form that your model can develop. So that's it can be trained on, and that's where you're doing some exploration and feature engineering. And this is, besides picking your model, this is the most important part of your pipeline is understanding your data, breaking it apart, all the pieces of your data, all the columns, all the records, cleaning it, simplifying it, explaining it. That's this part, the data exploration, feature engineering. Model verification, comparison, that's where once you've gotten your data in a certain form, then you apply your models and compare them through some mathematical techniques. Okay, then there's these geniuses out there that are putting together these models, creating the models from scratch, or just adding to models that are out there to come up with something that's more accurate, faster. So that's something that you don't have to do, and as a data scientist, but you're involved with that. And then there's the domain knowledge, which is your business end of it, your definition of your problem. Why am I doing this? What am I trying to accomplish? And then just your support. And visualization is also a big part of your data exploration, feature engineering. Make pictures worth 1,000 words. Well, this is where you can do that. Okay. And here, this is something Patil said a few years ago, that you're sometimes what you end up doing as a data scientist 80% of the time is getting your data ready. And I think this probably also should include the feature engineering, because that's also part of preparing your data for the model. So in that sense, yeah, it would make sense.